Hi everyone, we are going to discuss about the spatial mining and time series mining.
Spatial mining. What is spatial mining? It is the process of discovering interesting, useful, non-trivial patterns from large spatial datasets, example determining hotspots, unusual locations. Spatial data mining refers to the extraction of knowledge, spatial relationships, or other interesting patterns not explicitly stored in spatial database. Such mining demands an integration of data mining with spatial database technologies. It can be used for understanding spatial data, discovering spatial relationships and relationships between spatial and non-spatial data, constructing spatial knowledge bases, reorganizing spatial databases, and optimizing spatial queries. The core goal of a spatial data mining project is to distinguish the information in order to build real, actionable patterns to present, excluding things like statistical coincidence, randomized spatial modeling, or relevant results.
Unique properties of spatial patterns. Items in a traditional data are independent of each other, whereas properties of location in a map are often autocorrelated. Traditional data deals with simple domains, example, numbers and symbols, whereas spatial data types are complex. Items in traditional data describe discrete objects, whereas spatial data is characteristics of spatial data mining. Autocorrelation. Patterns usually have to be defined in the spatial attribute subspace and not in the complete attribute space. Longitude and latitude are the glue that link different data collections together. People are used to maps in GIS, that is Geographical Information System. Therefore, data mining results have to be summarized on the top of maps. Patterns not only refer to points but can also refer to lines or polygons or other higher order geometrical objects. Large continuous space defined by spatial attributes. Regional knowledge is of particular importance due to lack of global knowledge in geography. Why regional knowledge important in spatial data mining? A special challenge in spatial data mining is that information is usually not uniformly distributed in spatial datasets. It has been pointed out in the literature that all map statistics are seldom useful, that most relationships in spatial datasets are geographically regional rather than global, and that there is no average place on the Earth's surface. Therefore, it is not surprising that domain experts are mostly interested in discovering hidden patterns at a regional scale rather than a spatial data mining tasks. First one is characteristics rule. It simply means general description of spatial data. Second one is discriminate rule. Description of features discriminating or contrasting a class of spatial data from another class. Example, comparison of price ranges of different geographical area. Third one is association rule. We can associate the non-spatial attribute to spatial attribute or spatial attribute to spatial attribute. Fourth one is clustering rule. It is helpful to find outlier detection, which is useful to find suspicious knowledge, that is group crime location. Last one is classification rule. It defines whether a spatial entity belong to a particular class or how many classes will be classified. Example, remote sensed image based on spectrum and GIS data. Second topic is time series mining. A time series is a sequence of data points recorded at specific time points, most often in regular time intervals, seconds, hours, days, months, etc. Every organization generates a high volume of data every single day, be it sales figure, revenue, traffic, or operating cost. Time series data mining can generate valuable information for long-term business decisions, yet they are underutilized in most organizations. Different techniques of time series analysis. Trend analysis. Just plotting data against time can generate very powerful insights. One very basic use of time series data is just understanding the temporal pattern or trend in what is being measured. In businesses, it can even give an yearly indication of the overall direction of a typical business cycle. Second technique is outlier or anomaly detection. An outlier in a temporal dataset represents an anomaly Whether desired or not, outliers detected in a dataset can help prevent unintended consequences. Third technique is examining shocks or unexpected variations. Time series data can identify variations and abnormalities, detect signals in the noise. Fourth technique is association analysis. By plotting bivariate or multivariate temporal data, it is easy to identify associations between any two features. This association may or may not imply causation, but this is a good starting point in selecting input features that impact output variables in more advanced statistical analysis. Fifth is forecasting. Forecasting future values using historical data is a common methodological approach from simple extrapolation to sophisticated stochastic methods such as ARIMA, autoregressive integrated moving average. Sixth technique is predictive analytics. Advanced statistical analysis such as panel data models rely heavily on multivariate longitudinal datasets. These types of analysis helps in business forecasts, identify explanatory variables, or simply help understand associations between features in a dataset.
Applications of time series mining. Stock market analysis, economic and sales forecasting, scientific and engineering experiments, and medical treatments, etc. Thank you.